Hi everyone, welcome to this episode of Keipert Labs. Today we're going to introduce acids and bases. So we're going to start by defining what we mean or by an acid or a base to kind of set a bit of a working definition to start us off. We're then going to look at some examples of different acids and bases we encounter, whether in the lab or in everyday life. And then we're going to look at some of the properties that acids and bases have that we might experience. So what do we mean by an acid or a base? Okay, we encounter acids and bases in a range of different contexts in everyday life. Some of them, safe and harmless and, intentional in, we might eat them or we might use them in cooking or all sorts of things, and others that are significantly more dangerous or more toxic. So you can see some different examples of them here. But we need to kind of set a bit of a baseline of how we're going to define what is an acid. How do we put a compound into that group or into the base group or into neither category? So an acid we're going to define as something that forms hydrogen ions, H+ ions. And then what happens in reality, you can see over here that the formula of this thing called H3O+, which is also known as hydronium. Okay, so the idea is that hydrogen ion, H+ ion, is actually just a proton. Okay, because a hydrogen atom is one proton and one electron. If you strip that one electron away, all you're left with is the proton, which is the hydrogen nucleus. So it's actually incredibly simple. And so, but the thing is that a proton like that is highly unstable, doesn't exist on its own in reality. We can think about it conceptually, but it's not there in reality. What happens is that most of the time that we're thinking about acids and bases, we're thinking about them in water. And so what happens is that proton latches onto an oxygen atom of a water molecule because there's so many water molecules around. And it forms this thing called hydronium, so H3O+. Okay, so when we're talking about this idea of forming H+ ions, we will interchangeably be talking about hydronium, and then that's tending to be the thing that we will be we'll more specifically talk that way. But how do you define a base? A base is something that forms hydroxide ions. So this is the definition that we're going to start with. We will look at more nuanced definitions in the future that kind of show a fuller picture, but this is what we're going to work with for now. The acids form hydronium ions and bases form hydroxide ions. Okay, so some examples of acids we might encounter: hydrochloric acid, HCl, H2SO4, sulfuric acid, nitric acid. Okay, so these are three really common kind of lab acids that we would be using or encountering. And then we've got some other ones more in everyday life. Acetic acid, which has this formula, which is the main component of vinegar. And citric acid, that gives the sour taste to citrus fruit like lemons and limes. Its structure is more complicated than this, but that's the simple kind of formula. Whereas some bases we might encounter: sodium hydroxide, used in drain cleaner, or it's called lye, L-Y-E, in lots of other things. Potassium oxide, which you'd use in potash, so something that you would have you'd add to soil to grow vegetables or grow plants. Sodium hydrogen carbonate or bicarbonate, so bicarb soda you'd use in cooking. Sodium carbonate, Na2CO3, also known as washing soda, that you often added to detergent to help clean clothes. Okay, so these are some examples of common acids and bases we encounter in the lab or in everyday life. So some of the properties that acids have, for example, we say that acids are corrosive. They have the tendency to sting or burn skin. Now, this is not in every concentration. You put a bit of vinegar on your skin and you're probably not going to notice it. But if you put really concentrated hydrochloric acid, you'll remember it very, very well. So we say they're corrosive because they will actually burn a hole through something like skin. They have a sour taste. They conduct electricity in solution because they produce ions in solution. And also they have the property of turning blue litmus paper, so a substance we might use, blue litmus paper, they will turn it red. Whereas then bases, we say they can be caustic. Now, caustic is very, very similar to corrosive. The effect is very similar, certainly, but we use this slightly different kind of term because the way that it works is different. Bases tend to have a bitter taste, so they're responsible for things like the taste of coffee and dark chocolate and things like that are based on bases or alkaline compounds. They have a soapy feel on the skin because they react with the fats and oils in your skin to produce soap. They also can produce ions in water, so they conduct electricity in solution. And the opposite of acids, they would turn red litmus paper blue in colour when something is basic. So we defined what we mean by an acid and a base. Acid produces hydronium ions, bases produce hydroxide ions. That we looked at some everyday and lab examples of both acids and bases, and we've gone through some of the properties that both acids and bases tend to have. All right, that's it. Thanks very much for watching. Don't forget to like and subscribe. Bye for now.